Let's talk about electricity. You think you know what it is, don't you? You use it constantly. Right now, as you're reading these words, electrons are moving inside the device in your hands or on your desk. Electricity is lighting the room around you, keeping food cold in refrigerators, charging phones, running hospitals, moving trains, and powering entire cities. It's everywhere. It feels ordinary, familiar, safe. So it seems reasonable to assume we understand it. But do we really? If I asked you to explain what actually happens when you plug something into a wall socket, could you do it without resorting to vague phrases? Where does the power actually come from? What is electricity at its core? Most people respond with answers that sound scientific but explain almost nothing. Electricity is energy. Electricity is electrons moving. Electricity is current in a wire. Those answers don't solve the mystery. They just rename it. Yes, electrons are moving. But why are they moving? What is pushing them? And why does that pushing create light, heat, sound, or motion? These are the questions we rarely stop to ask because the truth behind them is unsettling. The thing we call electricity is deeply, profoundly strange. And the way we usually teach it hides that strangeness completely. We smooth it over with metaphors and formulas. We make it sound normal and predictable. But once you really look at what's happening, once you peek behind the curtain, you realize we are manipulating something extraordinary, something that quietly breaks our intuition about how the world works. Let me show you what I mean. Take a simple piece of plastic wrap, tear off a strip, rub it quickly between your hands as if you're trying to warm them up. Now hold the plastic near the back of your hand without touching it. You'll feel the hairs on your arm start to rise. They stand up, stretch out, and reach toward the plastic. You can actually feel the plastic pulling on you through empty space. Pause for a moment and think about that. You rub plastic. That's it. No batteries, no wires, no power source, just friction. And now this piece of plastic can reach across air and tug on your body. How is that possible? In your everyday experience, forces require contact. You push a chair by touching it. You lift a book by grabbing it. You pull a door by holding the handle. But here, nothing is touching anything. And yet, a force is clearly acting. Most people shrug this off. Static electricity, something we learned about in school and quickly forgot. Something minor, something unimportant. But that reaction completely misses what's happening. You're not seeing a trick. You're seeing the same force that holds every atom in your body together. The force that makes chemistry possible. The force that allows your neurons to fire, your muscles to contract, and your eyes to see. You're seeing one of the four fundamental forces of the universe demonstrating its ability to act across distance. And we dismiss it as a party trick. This is the real problem. We've become so familiar with electricity that we've forgotten how absolutely insane it is. When you rub that plastic, electrons were transferred from your hands onto the plastic. Just a tiny imbalance. Maybe one extra electron out of every trillion atoms, an amount so small it seems meaningless. And yet, that microscopic imbalance was enough to lift your arm hairs against gravity. Why? Because electromagnetic forces are unimaginably strong. Take two electrons and place them just 1 centimeter apart. The electromagnetic repulsion between them is about 10 to the 40 second power times stronger than the gravitational attraction between them. That's a 1 followed by 42 zeros. Gravity, the force that shapes planets, stars, and galaxies, is essentially irrelevant at this scale. For electrons, gravity might as well not exist. Electromagnetic forces dominate everything. So here's the obvious question. If these forces are that strong, why isn't everything exploding? Why doesn't matter tear itself apart? The answer is almost magical. Cancellation. Every atom is an intricate balance of positive and negative charge. At the center are protons with positive charge. Surrounding them are electrons with negative charge. Like charges repel, opposite charges attract, and the magnitudes of these forces are exactly equal. In normal matter, positive and negative charges are packed together as closely as physics allows. Every positive charge is surrounded by negatives. Every negative charge is surrounded by positives. The enormous repulsive forces are cancelled by equally enormous attractive forces. The forces don't disappear, they're still there, acting constantly, but they balance so precisely that the net effect is zero. And because those underlying forces are so huge, even the tiniest imbalance produces noticeable effects. Move just a few extra electrons, and suddenly plastic can pull on your body through empty space. This realization should change how you think about matter itself. Pick up a mug and hold it in your hand. What are you actually feeling? It feels solid. It feels like your hand is touching ceramic. But that's not what's happening. The electrons in your hand are pushing away from the electrons in the mug. The reason your hand doesn't pass through the mug is not because of physical contact, but because electromagnetic repulsion becomes overwhelming at very short distances. There is always a tiny gap between the atoms in your hand and the atoms in the mug. Your hand never truly touches it. You have never touched anything in your entire life. Every sensation of touch, pressure, resistance, or solidity is electromagnetic repulsion and attraction acting across space. Every push and pull you have ever felt is electrons pushing against electrons through empty space. What you experience with the plastic wrap is the same force, just acting at larger distances where you can clearly feel it. Now let's talk about wires. Imagine a copper wire running through your house. At one end is an outlet. At the other end is a lamp. You flip the switch, and the lamp turns on instantly. What just happened? The standard explanation is that electricity flows like water. Electrons enter the wire at one end, travel down its length, and emerge at the other end. That explanation feels intuitive, but it's wrong in the most important way. Electrons in a copper wire move incredibly slowly. Their average drift speed is about 1 millimeter per second. At that speed, it would take many minutes for an electron to travel across a room. And yet, the lamp turns on almost instantly. So what's really happening? The wire is already full of electrons. Copper contains a vast sea of mobile charges, all packed closely together. When you close the switch, you create a voltage difference. That voltage creates an electric field that pushes on electrons everywhere in the circuit at once. And because electrons repel each other, that push is transmitted through the wire at nearly the speed of light. It's not electrons racing through the wire that matter. It's the force being transmitted. A better analogy is a tightly packed line of people standing shoulder to shoulder. If you push the person at one end, the person at the other end feels it almost immediately, not because someone ran down the line, but because the push traveled through the crowd. That's what makes electricity useful. You can apply a push in one place, and something responds somewhere else almost instantly, even across vast distances. Now trace that push backward. Your lamp connects to an outlet. The outlet connects to wires in your walls. Those connect to power lines, which lead to a power plant miles or even hundreds of miles away. At that power plant, something massive is spinning, a turbine weighing tons, rotating thousands of times per minute. And that spinning motion is what powers your lamp. How is that possible? The connection is magnetism. Electricity and magnetism are not separate phenomena. They are two aspects of a single unified force, electromagnetism. Moving electric charges create magnetic fields. Changing magnetic fields push on electric charges. You cannot have one without the other. Spin a coil of copper wire inside a magnetic field, and the magnetic field pushes on the electrons in the wire, forcing them to move. That's a generator. Push electrons through a wire inside a magnetic field, and the wire moves. That's a motor. Same process reversed. This means motion in one place can cause motion in another place, connected only by thin copper wire. Water falling behind a dam can make a fan spin in your bedroom miles away. Metal influencing metal across empty space using invisible fields. That should sound impossible, and yet every motor, every generator, and every power grid on Earth operates on this principle. You don't even need permanent magnets. Run electricity through a coil of wire, and the moving electrons create a magnetic field. Bring that coil near another coil, and the changing magnetic field pushes electrons in the second coil. Current flows without any physical connection. That's a transformer. That's how electricity is transmitted efficiently across continents. Just copper, just motion, just fields. Now consider what this means for reality itself. Every force you feel in daily life, every push, pull, step, and touch is electromagnetic. Mechanical forces are not fundamental. They are consequences of electromagnetic interactions. When you walk on the floor, you are being held up by electromagnetic repulsion. When light enters your eyes, oscillating electromagnetic fields move electrons in your retina. Chemistry is electromagnetic attraction between atoms. Biology is chemistry. Your entire sensory experience of the world is electromagnetic. And here's the deepest part. You can't explain the electromagnetic force in terms of anything simpler. You can't say it's like a spring or a rope, because springs and ropes are made of electromagnetic forces. It's fundamental. One of the basic facts of reality. That's uncomfortable because it violates intuition. We evolved to understand contact forces, but contact is an illusion. The universe is made of fields that permeate space, and particles push and pull on each other across those fields. When you flip a light switch, electrons throughout the entire circuit begin to move slowly. At the power plant, turbines spin. Magnetic fields change. Electrons are pushed. That push propagates through hundreds of miles of wire at nearly light speed. It reaches your home. Electrons squeeze through a filament. Resistance turns their motion into heat. The filament glows. Electromagnetic waves radiate outward. Some reach your eyes. Electrons in your retina move. Chemical signals fire. Your brain sees light. Every step is electromagnetic. 200 years ago, none of this existed. Then humans discovered these forces, learned their rules, and figured out how to manipulate them. We built machines that generate electricity, transmit it across vast distances, and use it to do work. Electricity gave us instant communication, artificial light, powerful machines, and computation. It reshaped civilization. And it all rests on one astonishing fact: the universe allows forces to act across distance, and we learned how to harness them. So what is electricity really? Electricity isn't a substance. It isn't a fluid. It's what we call the controlled manipulation of the electromagnetic force to do useful work. But more than that, it's proof that the world is not what it seems. Solid matter is an illusion. Contact is an illusion. Reality is fields and forces pushing and pulling across empty space. So the next time you flip a switch, remember this. You're not just turning on a light. You're commanding fundamental forces. You're making electrons push each other across cities. You're converting motion into fields and fields back into motion. You're wielding power over nature itself. And that is the real story of electricity.